Want to know what makes machines tick and ideas spark? Welcome to Electrotechnics. Here, we dive into science. Here, we dive into tech. Here we dive into the magic behind everyday stuff. From building gadgets, breaking down big ideas. I'll show you how knowledge turns into cool inventions. Hit subscribe. Let's explore the genius of our world. One discovery at a time. Alright, quick question. What's the invisible MVP that makes your computer feel alive? System, software, hook time. If hardware is the body, screens, chips, keyboards, then system software is the brain and nervous system. It wakes everything up, moves the info, keeps the peace, and lets your apps do their thing without melting your laptop. And today, I'm breaking it down in the simplest way possible. Hook, define, demo, recap. Let's go. Define. System software is the core layer that sits between your apps and your hardware. Windows, macOS, Linux, iOS, Android kernel. The boss at the center. Drivers. The translators for every gadget and chip. Firmware. The tiny code inside your hardware that boots first. Utilities. Things like file managers, antivirus, and system monitors. And services. Background helpers that sync, schedule, index, and update. The job? Abstract the messy hardware. Share resources fairly. Keep things secure and make your apps think the machine is simple, even when it's not. How does it actually work? Step 1. Boot. You press power. Firmware. BIOS or UEFI. Wakes up and checks the basics. Memory? Check. Storage? Check. It finds the bootloader on your drive. That bootloader loads the kernel, the brain of the operating system, into memory. Kernel takes over. It sets up memory management device drivers and a scheduler, the traffic cop for your CPU. Then it starts system services and launches the login screen or home screen. Boom, you're in. Step 2, run an app. You click a browser. The OS creates a process. That's a container with your app's code, memory, and permissions. It gives that process threads. The to-do list the CPU actually runs. The scheduler slices time into tiny chunks and hops between tasks crazy fast. To you, it feels smooth and simultaneous. Step 3, ask for stuff. Your app needs files, network, or graphics. It makes a system call, a polite knock on the OS door. Hey, I need to read this file. The kernel checks permissions, locates the data in the file system, and talks to the storage driver, which talks to the SSD controller, which grabs the blocks, which sends them back up the chain. Your app just sees file opened. Magic? Nope. System software. Step 4, handle devices. You plug in a mouse, a mic, or a gamepad. Drivers identify it, the OS loads the right translator, and suddenly your cursor moves or your voice records. Different brands, same experience. That's the hardware abstraction layer making everything feel consistent. Step 5, keep it safe and fast. Memory management keeps your apps from stepping on each other's toes. Virtual memory maps each app into its own sandbox. If an app misbehaves, the OS can stop it. Permissions and users keep secrets safe. Background services index files for quick search, sync your cloud stuff, and watch for updates. Power management dials the CPU up for performance or down to save battery. Demo time, picture this. I open a photo editor. I drag a huge image. The app requests memory. The OS assigns it. I hit sharpen. Threads spin up. The scheduler slices CPU time across cores. The GPU driver takes the heavy lifting and crunches pixels in parallel. I hit save. System call to write. File system turns it into blocks. Storage driver flushes it to the SSD. Power flickers. Journaling in the file system helps prevent corruption. I close the app. Resources are released. The system stays stable. Why should I care? Because good system software means your machine feels fast, secure, and reliable. It decides whether your battery lasts, whether your game stutters, whether your files survive a crash, and how many apps you can juggle before everything freezes. Bonus round. Updates? They patch security holes and optimize performance. Drivers? They keep new hardware and games running right. Virtualization? It's system software simulating a whole other computer so you can run another OS inside your OS. Cloud? Same principles, just spread across giant racks of servers with orchestration doing the scheduling at planet scale. Recap. System software is the foundation. Firmware boots. Kernel commands. Drivers translate. Services support. Utilities maintain. Together, they make apps fly and hardware behave. Next time your laptop launches a video, installs a printer, or survives a sketchy tab without crashing, thank the invisible MVP. System. Software. If this helped, hit like, drop a question, and tell me what part of your system you want me to tear down next. I got you.